Alright, let's look at what I like to call understanding numbers, right? So, when you look at sum, you have to think as adding, right? So the sum of 8 and 2 is just 8 plus 2, right? 8 plus 2, which is 10. When you look at product, you have to think multiply, right? So the product of 8 and 2, 8 times 2 is 16. Alright, the difference. When you think of difference is subtraction. Alright, so the difference between 8 and 2, so you take, if this was if this said 2 and 8, you still would take bigger minus smaller equals 6. Alright, and the difference is 6. Here, the product is 16. Here, the sum is 10. Alright, the quotient. The quotient is the answer to a division problem. So the quotient of 8 divided by 2 is 4, right? So your quotient is 4. Alright, let's look at this example, right? They say the sum of two squared numbers is 25. What are the two squared numbers? So I have a squared number, let's call it one number x, plus another number, we could call that y. Alright, and they said the sum of two squared numbers is equal to 25. Alright, I don't have much squared numbers, alright, that goes over 25 like that. Right, 6 squared is already 36, so I know it can't be 6. None of these can be 6. 5 squared is 25, but it says two squared numbers. 4 squared is 16, so it could be 4, right? It could be 4. So one of these could be 4. One of these could be 4 squared, because 16 is equal to 4 squared, right? Because in actuality this is 4 times 4, so that could be 4 squared. And then 3 squared is 9, so that's 9, and that's 3 squared, right? Because this is actually 3 times 3. So the two squared numbers, more than likely, yes, is 6 plus 9, and that gives me 25, right? So my two squared numbers, 4 squared plus 3 squared equal to 25, right? My two squared numbers is 4 and 3. So if they ask you for the two squared numbers, it's 4 and 3.